Hello, my name is Eva Loth. I'm a reader in psychology at the Institute of Psychiatry, Psychology and Neuroscience at King's College London. I'm also the deputy lead of the AIMS-2-TRIALS consortium, and I'm the co-lead of the work program on biomarker identification and validation. In this video, I'm going to introduce you to the Preschool Imaging Project. We also sometimes call it PIP. This project aims to identify early markers and mechanisms of neurodevelopmental conditions throughout the preschool age range. Perhaps I start off by telling you a little bit about what motivated this particular project. We now recognize that autism is a very diverse condition, and also there are loads of overlaps between autism and other neurodevelopmental conditions, such as intellectual disability or developmental delay, ADHD, but also co-occurring mental health conditions such as anxiety or depression. So one of the big questions for us is, how can we predict the developmental course of a particular child or a particular person? In PIP, we start at an age range where children are typically first diagnosed with autism or other neurodevelopmental conditions, so very roughly between the age of 3 and 4 years. And we're following children, about 500 children in total, seen across multiple centers in Europe on 3 time points between roughly 3 and 4 years, 4 and 5 years, and then 5 and 6 years. In addition to predicting developmental outcomes, we also want to better understand what are an individual child's needs and how we can best support them. And this depends on his or her individual biological or social or psychological profile. So, for example, some children have particular sensory sensitivities that might impact the way they deal with other people. Other children might find other people frightening, or they prefer to be on their own, or others develop anxieties that might prevent them to participate in different interactions, perhaps in the playground with other children. So I believe that PIP has 2 novel features. One is that we are comparing multiple neurodevelopmental conditions. So not only autism and typical development, but we are comparing autism, ADHD, epilepsy, and intellectual disability or developmental delay. And the second feature is that we want to go beyond a description of mean group differences to create individual profiles of each child. And then, if you like, from the bottom up, want to see whether those characteristics are shared within a diagnostic category, like autism, or might stretch between diagnostic categories. We aim to comprehensively characterize each child at different levels. That means we use questionnaires and interviews to understand the level of their autistic features, ADHD features, but also level of what we call adaptive functioning, what they can do in their everyday life. We also assess their quality of life, but then we are interested also in their family psychiatric history. We are interested in their what we call cognitive profiles. So, for example, their memory, their ability to control particular responses, their understanding of social situations, what they're looking at when they are watching a video, what they're most interested in. We assess brain function during some of these processes using EEG. And we also use MRI scans while children are asleep in our special MRI sleep tent to also measure brain developments of brain structure and white matter difficulties, and also different levels of particular neurotransmitters. So in the first instance, we will carry out these traditional group comparisons to see whether there are any average differences between autism, ADHD, intellectual disability, and typical development, and also whether there are average differences, for example, between girls and boys. But then in the next step, and this is much more innovative, we're trying to create these individual profiles for each child. And we do that by using an approach that we call normative modeling. It's a little bit of an unfortunate term, but what it means is we're trying to create kind of growth charts that you might be familiar with when you go to a pediatrician who has growth charts for typical weight and height of a 6-year-old child, say, for example, if they're a boy, and what is typical, what is a bit bigger than normal, what is a bit smaller than typical. And we're trying to do the exact same thing for pretty much all of our assessments, so that we have these growth charts for social cognitive development, for cognitive development, for brain structural development, in particular brain regions, and so on and so forth. So we can have individual scores for each person on these different variables. And then we can put them all together to create a big chart and a big profile of each child, and we can see those are this person's relative strengths and this person's relative weaknesses compared to expectations based on their age or based on being a girl or a boy. So based on these individual profiles, we then use techniques that are called, for example, clustering approaches, to try to identify different subgroups or subtypes of children who show similar types of profiles. And we're doing this during our first assessment wave when the children are roughly between 3 and 4.5. And then we try to use these profiles or these subgroups to predict a child's development over time. So for example, whether group 1 has more gains in social development than group 2, or whether group 1 is more likely to develop ADHD features. So for example, if they're autistic children at age 3, which group is more likely to develop ADHD later on in childhood, or which child is likely to make gains in their cognitive development. So if you have a better understanding of a child's current profile and likely developmental course, we can also sit together with parents and see what might be the areas where interventions or therapies might be desired. And so this gives us a better angle to see, well, this person might naturally show improvements in particular areas where parents might be concerned, or another child may have less of a likelihood to improve. And then this opens up the question then to see, do we want to find a therapy that might address this particular feature for this particular child. As some of you will know, having a brain scan can be quite a scary experience, not only for a child, but also for adults. So we've been working with an artist to make the whole MRI sleep scan experience much more exciting and less scary for our children. For example, we created a video called Pip and the Brain Explorers, which uses puppets and shows children in a child-friendly manner what a sleep scan entails. It features puppets who have different sort of like neurodiverse features, and they want to find out what's different between them.
Oh, hello. My name's Pip.
And we also created this MRI sleep tent, which is a lovely tent, all around the MRI scanner with space friends, and it makes it a lot more warm and fun and exciting and less scary for children to lie even in the scanner. So our PIP study is ongoing. It's carried out in 5 different sites across Europe, in King's College London here in the UK. It's also carried out in Paris, in Sweden, at the Karolinska Institute, in Ghent, in Belgium, and also in Nijmegen in the Netherlands. If you'd like to find out more about our PIP study or have a child roughly between the age of 3 or 4 years and might be interested for him or her to take part in our project, please visit our website. It's www.AIMS-2-TRIALS.eu/PIP, and that takes you then to the different site-specific websites.